Bismillahirrahmanirrahim. We are going to start question number 3 of exercise 2.3, which says that we have to find which of the following matrices are singular. For singular matrices, the determinant of the matrix should be equal to 0. So if the determinant of any matrix equals 0, then it would be a singular matrix. I forgot to tell something in the previous video of question number 2, exercise 2.3, which was that if we expand it through row 1, row 2 or row 3, through any row, our answer would be the same. There is no difference in the answer. Expanding through any row or any column, we have not expanded through any column yet, but if we expand through any column or any row, there would be no difference in the answer. Okay, now here we are going to start by writing the numbers 3 1 2 2 3 1 and -4 1 -3. I just forgot to change the color. Okay, now here we are going to expand using row 1. Expand using row 1. So we are going to write it as equals to positive, negative, positive. So positive 3, then a 2 by 2 matrix determinant, then a -1, and then again a 2 by 2 matrix determinant, and then +2, and then again a 2 by 2 matrix determinant. Now what are we going to write in between these brackets or determinants? For 3, we are going to leave this column and this row, and the rest of them are 3, 1, 1 and -3. Then for -1, we are going to leave this row and this column. So the leftover are 2, -4, 1, -3. So 2, -4, 1, -3, and then +2. We are going to leave this column and this row, so we are left with these 4 terms, which are 2, 3, -4 and 1. Now we are going to open these determinants, so we get 3 into 3 gives us 9, and with a negative sign, so -9 minus, because there is a negative sign between the product of the two diagonal or non-diagonal entries, and then 1 into 1 gives us 1, -1 will remain as it is, and then finding the determinant, the diagonal entries are multiplied -6, and then a negative sign is multiplied with -4, so we get a positive sign, because negative with -4 gives us +4. Then +2 will be written as it is, so +2 into 2 into 1 gives us 2, now -4 into 3 gives us -12, and -12 into negative sign gives us +12, which is equal to 3 into minus sign -1 gives us -10, -1 into -6 plus 4 gives us -2, plus 2 into 2 plus 12 gives us 14. It is equal to -30, -1 into -2 gives us +2, plus 14 into 2 gives us 28, and when we solve it through calculator we get the answer 0. So what type of matrix is this? It is a singular matrix, because we've seen that its determinant equals 0. Now moving towards the next part, which is part number 2. Again, changing it from matrix form to determinant form, it is equal to 3 -1 2 2 0 1 and -1 5 1. There is only 0 in the second row, so we are going to expand it using this row, because we prefer using the rows which contain 0. So for the second row we have the rule. First of all, we should write here expand using R2. Okay, now this is negative, positive and negative for the second row, so -2 and +0, which is no use, and then a -1, so -2 with a 2 by 2 order matrix, and then a -1 again with the 2 by 2 order matrix determinant. Now what are we going to write in these determinants? For -2, we are going to leave this column and this row, and we are left with -1 2 5 1. So -1 2 5 and 1, and then for -1 we are going to leave this column and this row, we are left with 3 -1 -1 5. So 3 -1 -1 and 5. Now we are going to solve it. -2 into -1 into 1 gives us -1 with a negative sign in between the two product of the two diagonals, and then 5 into 2 gives us 10. -1 will remain as it is, and then 3 into 5 gives us 15. Negative sign, -1 into -1 gives us 1. It is equal to -2 into -10, -1 gives us -11, -1 into 15, -1 gives us 14, minus 2 into minus 11 gives us 22, minus 14, which is equal to 8. And this is a non-singular matrix because the determinant is not equal to 0, non-singular. Now we are going to move towards part 3. Now again we have to change the matrix form into the determinant form. So we are going to write it in this way: 3 iota, 1, 2, minus 4, 1 iota, and 2, 0, 1. Again there is only 0 in the third row, so we are going to expand using R3. And now for R3 it is positive, negative and positive, so 2 and 1 would be positive and 0 would be negative and it has no use, so we are going to write it as 2 into a 2 by 2 matrix determinant, and then plus 1 with again a 2 by 2 matrix determinant. Now we are going to leave this row and this column for this matrix and we are left with 1, 1, 2 iota. So 1, 1, 2 and iota. Positive 1, and then we are going to leave this column and this row and we are left with these 4 terms. So we are going to write them as 3 iota, 1, minus 4 and 1. Now we are going to solve it. 2 into 1 into iota gives us iota, minus 1 into 2 gives us 2, plus 1 into 3 iota into 1 gives us 3 iota, minus sign will remain as it is, and minus 4 into 1 gives us minus 4, and when this minus 4 is multiplied with this negative sign we get a positive 4, which is equal to 2 iota minus 2 iota minus 2 into 2 gives us 4, plus 3 iota plus 4, negative 4 and positive 4 are cancelled, and 2 iota plus 3 iota gives us 5 iota, which is not equal to 0. So this matrix is also non-singular. Now we are going to do part 4. This is your part number 4. Again, writing it in the form of determinant, which is equals to over here. Just wait for a while. Okay. Equals to, okay, 2, then iota, and then minus 2 plus iota. For this column we have minus iota, 3 and iota plus 3, and then 1, minus 2 and minus 3. Now from which row should we expand? This row would be quite difficult because there are greater numbers to multiply, and for these two rows you can choose any and check if your answer matches with mine. I'm going to expand using row 2. For row 2 we are given with negative, positive and negative. So negative iota, positive 3, and negative into negative 2 gives us positive 2. So we are going to do it as negative iota into this, and then positive 3 into again a determinant, then we get negative into negative 2, so we get positive 2 again with the determinant. Always remember that whenever we draw determinant over here after expanding, we always use 2 by 2 order determinants. Okay, for minus iota, this is a term. We are going to leave this column and this row, and we are left with minus iota, 1 iota plus 3 and minus 3. So we are going to write it over here: minus iota, 1 iota plus 3 and minus 3. Then for this plus 3 we are going to remove this row and this column, so we are left with these 4 terms, the corner terms. So we are going to write them as 2, 1, minus 2 plus iota, and then minus 3. And for minus 2, sorry, this is minus 2 and there is it's plus 2. We are going to remove this column and this row, and we are left with 2 minus iota, minus 2 plus iota, and iota plus 3. So it is 2 minus iota, minus 2 plus iota, and iota plus 3. Now we are going to open up these determinants. So minus iota into minus 3, minus iota gives us 3 iota, minus into iota plus 3 into 1 gives us iota plus 3. Just wait for a while, these are square brackets, okay? And minus into iota plus 3, then we get plus 3 into 2 3s are 6, and negative sign remains same, then a negative sign, and then negative sign is multiplied with minus 2 plus iota, then we get plus 2 as it is, and then 2 into iota plus 3, the diagonals are multiplied, 2 into iota plus 3, and then a negative sign, and negative into minus iota gives us plus iota into minus 2 plus iota. minus 2 plus iota. Okay. Now the next step would be minus iota into 3 iota. Minus into iota plus 3 gives us minus iota minus 3, then plus 3 into minus 6 remains same, and then this negative sign is multiplied with both the terms in brackets, so we get minus 6 plus 2 minus iota, then plus 2 remains as it is, and 2 into iota gives us 2 iota, and 2 into 3 gives us 6, so 2 iota plus 6, then iota is multiplied with these terms, so we get minus 2 iota plus iota square. It is equal to minus iota into 3 iota minus iota, we get 2 iota minus 3 as it is, plus 3 into minus 6 plus 2, we get minus 4, minus iota is written as it is, then plus 2 into 2 iota minus 2 iota are cancelled, and this is minus 1. Iota squared equals minus 1. Let me write it over here. Iota squared equals minus 1. So 6 minus 1 gives us 5. Now we are going to multiply iota with these terms. So negative iota, so minus 2 iota square. Minus into minus gives us plus 3 iota. Plus 3 into minus 4 gives us minus 12. And plus 3 into minus iota gives us minus 3 iota. Plus 2 into 5 gives us 10. Now we get minus 2 into minus 1. Then this plus 10 and minus 12. And then plus 3 iota and minus 3 iota are cancelled. And we get 2 plus 10 minus 12 give us minus 2, so we are going to remove it, and we get minus 2, which are cancelled, and we get 0. And whenever the answer is 0, we know that the matrix is singular. So your part number 4 matrix is singular, part number 2 and 3 are non-singular, and part 1 is also singular. And this is the end of your question. Thank you so much.